Have you ever, stared at a massive spreadsheet or just a huge pile of raw data and wished you had some kind of superpower, to instantly turn it all into clear, actionable insights?
Definitely felt that pain.
Well, today we're diving into a tool that gives you a version of that superpower. It's the programming language R, specifically for data mining.
Right.
We've got a great set of sources here from Professor Devi Mareva's Data Mining Lab course, MGMT 17300. It really lays out the basics, operations, data structures in R.
Yeah, it's a solid foundation.
Think of this deep dive as your shortcut, a way to grasp the fundamentals, even if you're totally new to coding. Our mission: demystify R, show you how it works as this powerful analysis tool, and highlight those key bits of knowledge that can really change how you deal with information.
And what's fascinating, I think, is how programming, especially with R, isn't just about typing commands.
Right.
It's more a structured way of thinking. It lets you automate things, explore patterns, find meaning in just vast amounts of data.
So it structures your approach.
Exactly. This deep dive will give you that foundational understanding connecting the what R does to the why. It really matters for anyone working with data today.
Okay, so where do we even start with this coding superpower? Our sources mention this fun YouTube video, Exact Instructions Challenge PB&J.
Oh yeah, that one's great.
It really makes you think how precise computers need us to be. But let's start simpler. R as just a really good calculator.
That's a perfect entry point.
You can just type 1 + 2 + 9, 4, bam, R gives you the answer. Or even 4 + 3, 102, it gets order of operations.
It handles pi.
Yeah, pi 3, it does scientific notation like 5, 102, or the tiny 510 to 2.
With big numbers too. That 111, 111, 11, 11, 11 example.
Right, it just handles it. It's pretty intuitive for that basic math stuff.
But that raises a key point. Once you calculate something, how do you, hold on to it? So you don't have to type it again.
Good question.
That's where scripts and objects come in. They're like R's memory. You assign values to objects, basically variables. So instead of just calculating 4, you type find as 4.
Ah, that arrow thing.
Yep, the assignment operator. Now A is 4, and you can build on it.
Yeah.
A 5 makes A become 20.
Okay, so you're updating its value.
Exactly.
Yeah.
Then a plus 10, now it's 30. This simple idea of storing and manipulating values in objects, it's fundamental for anything more complex.
So A isn't just a number anymore. It's like a container we can update. Makes sense.
That's precisely. And we can go beyond single values.
Yeah.
R uses vectors to store sequences. Think of a vector like a list, an ordered list.
Okay.
The C function, that C for combine or concatenate, is how you build them, like numbers, sin DC, 1, 4, 10, pi 13. Now, numbers holds all those values.
A list of numbers. Got it.
But here's a key thing to watch out for.
Yeah.
R likes vectors to have elements of the same type. So if you mix numbers and text, R will make everything text.
Yeah.
So if you have text, my CAB Daniels Business School, and combined with numbers using altogether fine C numbers, text.
Everything and altogether becomes text.
Yeah.
Even the numbers.
Exactly. Even pi becomes 3.1415 as text. This is called type coercion. You got to be aware of it because you can't do math on text that looks like numbers.
Right. That could mess things up badly. Okay, so as we write more code, it's not just about the computer understanding, is it?
Not at all.
Our sources have this great Hal Abelson quote, "Programs must be written for people to read and only incidentally for machines to execute." What's the deal with coding style?
That quote is spot on. Code isn't just for the machine. It's for your future self, for your teammates. Good style makes it readable.
Like naming things clearly.
Exactly. The sources push for descriptive object names. Think about eSnake case versus other people use camel case, or some people use periods.
Yeah, consistency seems key.
It's crucial. Without it, code becomes a nightmare to debug or understand later. That's why things like the Tidyverse style guide exist to provide a common framework. Makes everything cleaner, more maintainable.
I can totally see that. Saves a lot of headaches down the line, like turning cryptic notes into clear instructions.
You got it. And if good style makes code understandable, functions make it powerful and efficient. Functions are the real workhorses in R.
Workhorses, okay.
They automate stuff. Things that would take forever, be error-prone, or just super tedious to do by hand. We've actually seen some already.
Like install.packages.
Yep, and library to load them
Yeah.
for session info, for system details. Think about calculating the mean of, say, 1,000 numbers manually. Forget it.
Yeah, no thanks.
In R mean, 1.1000, done. And notice that 1.1000 automatically generates that whole sequence from 1 to 1,000 for you. Huge time saver.
Wow, okay. That really shows the power. It's like that idea of laziness being a good trait for programmers finding the efficient way.
Exactly right. Efficiency is huge. What if you need the mean of just the odd numbers from 1 to 1,000? Typing those out? No way.
Definitely not.
That's where seek comes in. Seek from 1 to 1,000 by 2. That generates just the odd numbers. Store it, maybe odds 8, then just mean odds. Simple.
Okay, seek for sequences. Very useful.
And R is packed with statistical functions. Beyond mean, you've got SDC for standard deviation, VAR for variance range, IQR for interquartile range.
Lots of stats tools.
But summary is fantastic for a quick look. Summary odds gives you the min, max, quartiles, median, mean, an instant overview of your data's shape. It's often the first thing you do.
A quick health check for your numbers. Nice. Okay, so R does math, stores stuff, automates with functions. But how does it know the kind of data? Ages versus job titles, like you said.
That's where data types are critical. R categorizes information.
Like different boxes for different things?
Pretty much. The sources list the main ones. Numeric, that can be double for decimals or integer for whole numbers. Text is character. Factors are special for categories like low, medium, high.
Factor centers.
And logical for true-false values, plus some special ones. NA for not available or missing data, super important. NLL, in for infinity. NaN for not a number.
NA seems really practical for real-world data.
Absolutely essential. And you can check an object's type with typeof. Knowing the type ensures R treats your data correctly.
Got it.
And bringing this all together, the most common structure for analysis in R is the data frame.
The data frame. Okay.
Think of it like, well, like those vectors we talked about, but lined up side by side, like columns in a spreadsheet.
Ah, okay, like a table.
Exactly. The sources have a nice example. Say you have vectors.names, major, time company. You combine them into a data frame. Team-data.frame, names, major, timing company.
So data.frame creates it.
Yep. And this structure is powerful because it fits the idea of tidy data. Each row is one observation, each column is one variable or attribute, clean and organized.
Tidy data. I like that.
Once it's a data frame, you can quickly ask questions. Quarantine for number of rows, quarantine for columns, CAD. Team shows the first few rows. Summary team gives you a summary for every column. Instant overview of the whole data set.
That sounds incredibly useful for getting oriented, like a well-organized filing cabinet. So once data is tidy in a data frame, how do you pull out specific pieces? That's subsetting, right?
Yeah, your next superpower. Pinpointing information. Surgically extracting what you need.
So back to that odds vector. If I want the 287th odd number...
Simple. Odds 287. The square brackets are key for subsetting.
Okay. What about several numbers, like the first, 76th, and 48th?
Use that C function inside the brackets. Odd C1, 76, 48.
Cool. Can you exclude numbers, like everything except the first 250?
Yep. Use a minus sign. Odds C 1.250, the minus means exclude these indices.
Wow. And based on the values themselves, like only odds greater than 900.
Absolutely. Odds 900. You put the condition right inside the bracket.
Yep.
Bar figures out which elements meet the condition and returns only those. Super flexible filtering.
That's powerful. How does it work with data frames? A bit trickier.
A little, because you have rows and columns. You use the format data frame, row condition, column condition. Comma separates rows and columns.
Row, comma, column.
So team 1-3 gets the value in row 1, column 3. If you leave one blank, you get everything. Team 1 gets the whole first row.
All columns for row 1.
Right, and team 3 gets the entire third column.
All rows for column 3. Makes sense.
But for selecting columns, often the operator is easier and more readable. Team timing company just gives you that whole column as a vector.
Oh, I like the sign. Seems clearer than remembering column 3 is time company.
Exactly. And for more complex filtering, you need logical operators.
Logical operators, like in math class?
Kind of. Your comparison tools for a dumity is exactly equal to note, the double equals.
Ah, double equals. Important.
For not equal to, then your standard do to db.
Yeah.
And to combine conditions for A and D, that vertical pipe, for OR.
And for A and D, for OR. Okay. So how would I use those if I wanted everyone in the team data frame who's been there exactly 10 years?
You'd write team time at company equals 10. Notice the condition goes in the row part, and we leave the column part blank to get all columns for those rows.
Got it. Team time at company equals 10 finds the right rows. What about, say, people with less than 5 years or people whose major is business?
Combined with the OR operator, team time at company, 5 team major equals business S.
Okay, for OR. That lets you build really specific filters, slice and dice the data exactly how you need it.
That's the power. Asking precise questions, getting precise answers.
So R itself is powerful, but you mentioned its real magic comes from packages, right? Like apps for your phone.
That's a great analogy. Packages add specialized capabilities. R's core is strong, but packages make it vast. The sources have that fun alien quote, "In space, no one can hear you scream." Kind of hints at the huge potential.
Okay. So how do you get these packages?
You install them once using install.packages,
Package down.
like install.packages, read Excel to read Excel files.
Install.packages. Okay.
Then, in each R session where you want to use it, you load it with library package name. So library.
Loads it for use. Got it.
And the Tidyverse is a huge collection of these packages. ggplot2 for amazing plots, dplyr for data manipulation, tidyr for tidying. They all work together really well. It shows how big the R community is.
The Tidyverse, I've heard of that. It's like a whole suite of tools.
Exactly. A very popular and powerful one. So once R is set up, package is loaded, the next big practical step is getting your data in. Data import.
Right. How do you feed the beast?
R is super flexible here.
Yeah.
It needs to be, right? Data comes in all shapes and sizes. How do you get that file from your computer into R?
Yeah.
You can use read.table for basic text files, .readXL. From that readXL package for Excel files, .read.csv is super common for comma-separated value files.
CSVs, yeah, those are everywhere.
You can even connect to SQL databases using packages like RODBC. Pull data straight from a server. For this course, the sources mentioned focusing mainly on Excel files, which readXL handles nicely.
Okay, focus on Excel for now. And after you do all your analysis, you need to get stuff out right. Share results.
Absolutely. Data export. Equally important. R gives you options here too. Write.csv is the counterpart to read.csv.
Write.csv makes sense.
Quick tip, use write.csv my data, my output.csv, row.names equals false. That row.names equals false stops R from writing its internal row numbers as an extra column, which you usually don't want in your final file.
Good tip. Row.names equals false.
You can use write.xsx from the write.xl package to write directly to Excel format, or write.table for more generic text files, maybe with tabs instead of commas.
Options. Good.
And there's also SaveRDS and ReadRDS. These are R-specific. They save any R object like your whole data frame with all its specific R properties to a file. Then ReadRDS loads it back into R perfectly later. Very efficient for saving your work within R projects.
RDS files for saving R objects. Neat. Okay, so we're learning, we're analyzing, but what happens when we get stuck or just want to learn about a new function? Where do you find help?
Crucial question. You will get stuck sometimes. Everyone does. The sources list great resources. First, right inside R, type bot followed by a function name like sum. Yep, that pulls up the official help file, your built-in manual. Then there's Stack Overflow online, a massive Q&A site for programmers. Chances are someone's asked your question before.
Stack Overflow, a classic.
And today, AI tools are huge. Claude AI, ChatGPT, Copilot AI, GitHub Copilot, Cursor AI. These can answer questions, explain code, even help you write it. They're like interactive tutors.
AI coding assistants.
Wow. And beyond just getting unstuck, how do you keep learning? That's also important, right?
Definitely.
The sources mention interactive platforms like Swirl. It actually runs inside R and teaches you R and data science step by step. And things like RStudio primers. The main takeaway is you're not alone. There's a huge community and tons of tools out there to help you learn and grow.
That's really encouraging. Okay, so let's recap this deep dive. What does it all mean for you, the listener? We've gone from R as a basic calculator to storing info in variables and vectors, organizing it all neatly into data frames. We saw why clean coding style matters, how functions automate tasks, and how packages give R superpowers.
Covered a lot of ground.
Plus, the practical stuff. Getting data in and out and knowing where to look for help, it really feels like R is the shortcut to becoming better informed, extracting knowledge quickly from data.
And if you zoom out, thinking bigger picture, mastering even these basics fundamentally changes how you interact with data.
How so?
You stop being just a passive consumer of charts and reports. You become an active architect of insight. You can dig in yourself.
Architect of insight. I like that.
It raises a question, doesn't it? With all the data flying around every day, news, work, everything, how could even a basic grasp of R empower you to, question things more deeply, to assess the claims being made, maybe even shape the narratives yourself?
Using the tools to see behind the curtain a bit.
Exactly. Think about how these tools don't just answer the questions you already have. They often reveal new questions you didn't even know to ask. That's where the real discovery happens. What was the aha moment for you today? What sparked your curiosity to maybe explore a bit further on your own?